Hello and welcome to the Flocode podcast, where we're dedicated to spreading the ideals of open source development, community collaboration, and engineering innovation. I'm your host, James O'Reilly, a civil structural engineer based in Vancouver, BC, Canada. Our mission is to empower engineers across the globe through a multi-dimensional approach to learning. We dive deep into technical topics, especially Python's potential in civil and structural engineering, alongside broader engineering-focused subjects like soft skills, economics, science, modern technologies, and industry trends. I'm extremely passionate about Python's application in our field, but I want to emphasize that Flocode's overarching goal is about fostering growth and continuous improvement. So we talk about a lot more than Python on this podcast. Check out the Flocode newsletter on Substack for more. The links are all in the description. And with that said, let's dive into today's episode. Welcome back, everybody. It's James again, and I am very excited today to introduce Mr. Bruce Hamersley, a structural engineer with over 37 years experience in bridge design, soil structure interaction, and some fantastically creative construction engineering solutions. In addition to contributing to a number of technical papers in the bridge industry, Bruce is recognised in 2019 for his professional contribution and was awarded fellowship with Engineers Canada. He's a mentor who opened doors for me when I landed in Canada, fresh from university, brimming with enthusiasm, but also hilariously deficient in terms of any practical engineering experience. So for me, this was a gateway to many different global engineering adventures, which both expanded my horizons and also profoundly shaped my career path. Today, Bruce is going to share with us his wealth of experience from highway and rail bridge design to seismic retrofits and bridge construction. And I will always be grateful to Bruce for taking a chance on me, and I am very happy to discuss some of his ideas and his engineering insights and to share some of the cool memories on some fantastic projects that we worked on. So, as always, thank you for listening, keep innovating, and I'll see you guys in the next one. Welcome back, everybody, to another episode of the Flocode podcast. Today, I have a very special guest, Mr. Bruce Hamersley, who is the guy who gave me my first job in engineering, and he can talk about whatever reason possessed him to do such a thing, but I'd rather dig into his career, his perspectives, and a whole list of topics that I want to talk about with Bruce. So, Bruce, welcome aboard.
Thank you.
I guess just to get started, your background is a broad variety of structural work, but your specialties are bridges, soil structure interaction, and I would say unusual structures. Well, how would you describe it?
I think that's right. It's my first job was working on nuclear power plants in Texas, and then I worked on pulp mills and cogen power projects, and then I moved into bridge engineering, but I did a lot of work in the hydroelectric field as well. And it tends to be the weirder the better for me.
Yeah, me too.
And unusual structures is something that is sort of where I made my mark. The stuff of I lay awake at 4 a.m. and figured out some solution to some weird thing. As those are my good memories, or my favorite things that I've accomplished and done.
So if we go back to, actually, first I want to talk about your education and your thought process on the material that you covered. I know it's a long time ago, but the way that engineering was approached back in school when you were there, like, what did you think of it, and how did you feel when you graduated? Because I know when I graduated, you're very, very busy. You're trying to cover so much material in such a compressed time frame, but it really is this, you're barely scratching the surface of the fundamentals. even though it feels like a mountain of information at the time. So what are your thoughts on that?
Yeah, I remember I went to UBC, and it was a 5-year program at that point. You had to do a first year of sciences, and then you went into engineering. And
That's the University of British Columbia here in Vancouver, Canada, for anybody out there. Sorry, Bruce, go ahead.
yeah, and it was um, I dabbled with the idea of going into just physics, and but there was my dad. My dad showed me this newspaper clipping when I was in grade 10 that was predicting a shortage of engineers. Of they 5 or 6,000 short engineers they were going to be short when I was by the mid 80s when I graduated. It turned out that 25% of all engineers in BC when I graduated were unemployed. It was the absolute opposite. So it was a terrible market. The worst. It was. I graduated into the worst engineering market in history, I think. And
Wow.
and but you're exactly right. It was kind of shocking to then get into industry and realize how little you'd actually knew. But what I was taught was how to research, how to learn, how to go find stuff, and but we really didn't learn much about the building code or the bridge code and things like that. Those were entirely new books to me. It was like, whoa, what's this? So, yeah, and then it was learned by talking to people and the various mentors who I could find to talk to and discuss and ask, and they would point me in the right direction.
And if you had a magic wand to advise on how universities should be structuring their engineering programs today, is there any sort of one or two key bullet points? I know for me, it would be, like you just said, you need to learn how to learn, because our industry is just so broad and vast. Chances are every project, there's going to be many things that you've never seen before.
That's right. I think there is a little bit of a watering down of the engineering schools and in Canada. There's just tons of them now. When I graduated, there was 7 accredited schools, and then they made all the community colleges, universities, and they have engineering programs, and we've had some fresh grads in recent years from some of these schools that I wasn't very impressed with the level of education that they got on the basic engineering fundamentals. They were well behind, I think, where I was when I graduated, and just the basics of statics and dynamics and that sort of thing. That really was that's the backbone of structural engineering. You have to be able to draw a free body diagram. When I graduated, I could draw a free body diagram. I could nail those. I had some really good professors who held your feet to the fire, and now you get kids coming out with free body diagram. They don't really understand it. Yeah. So there's more of the teaching that's forced onto the industry and the senior people.
Yeah.
And I don't know how to fix that. Right? I mean, that's just sort of a government policy thing that for whatever reason they did.
Yeah, well, say for example, now you started basis engineering, which is bridge specialty and other structures too. But how many staff have you got now?
15.
Do you have any internal policies for stuff like that for fresh grads about how you get them moving?
We have there's not a written policy, but there's a very strong feeling we have that there has to be some senior people who are in the office all the time, and that the juniors need to be in the office most of the time, because what I think we learned in COVID was the senior people and people with established working relationships can work independently, and everything sort of plunks along fine. But the juniors, the learning curve is just so flat for a junior working out of his basement or their bedrooms, and I think that that was, so you kind of have this really, really slow learning curve if you don't have that atmosphere. And William comes to the office every day, and he's the one who's mentoring the juniors, and you know how good William Wu is at mentoring, right? So so it's not an official policy, but it's certainly it's an unofficial policy.
Yeah. Yeah, no, I agree. Okay, so you mentioned some of the aspects of engineering that you find the most fulfilling, which is, and I'm the same way, it's trying to come up with a novel solution. The more novel, the better. And I remember, when we worked together, it wouldn't matter how ridiculous my suggestions for something were, you would always let me flesh it out and let me get to the end of it before you would hose it down with some common sense. But I just remember that you were always in the market for ideas, always.
Yeah. Well, I concluded sometime in my late 20s that I was really, really good at this. I was probably one of the best structural engineers in the business. But I also realized that a part of what that was that I'm a good listener, and I'm never so cocky that I think I've always got the best idea. And it can be the draftsman, it can be the junior engineer, and I always listen, and then if it's a good idea, then I take credit for it. Of course, that's what you do. We had they called me on the Patella Bridge project. Called me and they said we need a cart that's going to run along the top of the girder flanges, and so that we can set the EPS strips, so we can put the precast panels on the EPS strips. And we want a cart that's going to be 20 feet long, and the girders vary in width. They can't fall off, and it's got to go up over. So it's got to go up over top of diaphragms with Nelson studs and splice plates and stuff. And between Tien and I, we came up with, it's got 8 wheels, which are the trailer tongue wheels, and they go up and down with a cordless drill. And it's got a winch that works with a cordless drill, and the whole thing does this. And then it's got a mechanism for spreading the wheels out, and a mechanism for some horizontal jacks that hold it between the girders. And it's just about as much fun as you can have with your clothes on, for me, coming up with it. But I was listening. Tien would say something. I said, okay, that's, what we say, Tien, there's no such thing as stupid ideas, just stupid people. But, try again. And he came up with all sorts of goodies, and I came up with, and usually it was 4 a.m. Usually it's like, I don't know how this is going to work, and go to sleep, and then wake up and my brain has worked on it in the night. I go, oh, I know what we'll do. And so, yeah, absolutely. But listening is one of my most important skills. Right?
Yeah. I 2 of my favorite projects that I've worked on are the Queensferry crossing in Scotland, in Edinburgh. We had a blast working on that. There were so many fascinating structural scenarios with that bridge. And for those listening, the Queensferry crossing is it's a huge cable stay bridge in Edinburgh, Scotland. I think it's over 2.5 kilometers long. And at the time it was constructed, it was the biggest cable stay bridge in the world. And we had to do a very interesting analysis that was related to figuring out how much locked-in stress was developed as they constructed each of these huge steel box girder segments. And that whole process, Bruce, was fascinating, from not only that initial task and trying to figure out, we were doing those nonlinear analyses, trying to figure out the buckling behavior of the deck sections. We had that fascinating problem with the formwork supports and that second mode wind vibration. There were so many cool things with that project, as it all unfolded.
Yeah, that was. I remember getting a call about that from Sean Wickman, and we got a problem with the bracing, and these braces had gone into basically wind-induced vibration with vortex shedding. And I think you take a video? Somebody got a video of these braces, and they're just doing this, and it blows 100 miles an hour regularly there, and they were finding cracks emanating from the welded connections. And they phoned me, and they said, the designer says we should just drill a hole at the end of the crack. And I sounded the alarm. I said, get everybody off of the bridge. You gotta fix this. But it was the simplest thing to stop the vibration. Was just basically a strap to the midpoint. Boom, solved. Like zero vibration. Right? But then I remember sitting at my I was when they called me, I was up at Whistler, and I remember sitting at my dining room table drawing up the connection fixes with and I was doing it with using a CD as a circle to
you wouldn't find one of those nowadays.
Fixes on it, sketching this up at my dining room table on a Saturday morning. Then on Saturday afternoon, I'm on the phone with the president of American Bridge and the project director from, and saying, "You guys, this is really serious. You have to fix this. This will collapse if you allow it to continue." And they needed somebody to tell them that, right? They needed somebody to just smack them and say, "No, this is not okay. You can't just drill a hole at the end of this connection, this crack, and arrest it. That's not going to do it." Right? But
these platforms these temporary work platforms were maybe 50, 60 meters above the water level out in the channel. And I was up there, and you could feel that, well, the noise of the vibration was one thing, but you could feel this hum on the deck as you're standing there, and everybody was like, "What is that noise?" And I think that's how it started. People were just saying, "What the hell is that?" And when you looked, you could see those members just whoa, 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 whoa. It was a fascinating problem, and glad we got it straightened out. So that was a cool one.
The locked-in stresses was a really, really difficult problem too. I mean, that was like a 3 megabyte spreadsheet or something to actually try and track it. That was a really tricky problem too. Yeah.
I know, and that's something now that since I got into programming more the last few years, that I feel if I got the chance to tackle something like that again, I would be able to streamline. But I mean, that's engineering, isn't it? Yeah, if you get another swing at it, you're going to do it better. But what Bruce is talking about with the locked-in stresses is, if you can imagine a cable stay bridge that goes up in individual deck segments, as you lift those deck segments up, they're all stitch welded together, and then you gotta you got to also pour a stitch concrete pour between the deck sections, and you got to tension up your stay cables. But all of these different things are happening in production at the same time or at different times. And each one of these activities can lock in a different stress in the weld as it's being completed. So timing and understanding the limits of all of that work was a real head scratcher.
Yeah. Yeah, it was really interesting.
And I think when we were over there, Bruce, we had a workshop, and at the time I had come down with some insane flu. And I had some very strong cold meds at the time, and I can't remember what it was. We were discussing some very fundamental principle, and I said something completely ridiculous. Like I just flipped the formula around, and I was like, what about if we looked at it like this? And you just told me to just have a glass of water and stay off the cold meds. You get delirious when you're looking at the same problem for so long. You start thinking crazy. So tell me, if you were to boil down your approach to problem solving, what is it? You get a new problem, could be anything. Let's just say it's a conventional problem. Like, do you have a process?
Well, I mean, there is a fundamental mathematical problem-solving technique, which is you take a big problem and you break it down into as many individual small problems as you can, and solve them one at a time, and then put it back together. And that's part of it for sure. I use the term to describe myself as a slave to efficiency. I'm always pushing for efficient structures, and I find that I find this with bridges a lot. There's a philosophy that or design approach that is quite common in industrial engineering for people to be really conservative. I mean, there was a saying back in H.A. Simons when I worked there in the pulp mill business, which was nobody ever got fired from H.A. Simons for designing a beam too big. And in the industrial world, the cost of the structure is not really the big number. The big number is the equipment and that sort of thing. And so you can get away with it. And bridges, you can't. It's blatantly obvious if you've taken that approach, and people do. It's all over the place. Our bridge engineering right now is I'm constantly seeing stuff where we go, holy smokes, is that ever conservative? It's the we like to sleep at night engineering approach. You just double it, and it drives me absolutely nuts. It drives me completely berserk.
When you say that, initially I'm thinking like to big primary members, but you probably mean stuff like connections, secondary members, the stuff that's not so obvious.
It's a lot of it's in the foundation design and not really understanding how to do an efficient seismic design. And if people go down these paths with seismic design of you design it something that's a bit too stiff, and so it's got a shorter period than you need, which means that the seismic forces and the accelerations that are much higher, and then there's this circle of chasing your tail, and you add more piles, it gets stiffer, the forces go up, and around it goes. And I've seen designs with 22 piles when we could do it with 9 piles. I mean, like literally that sort of difference. And a lot of that's just not understanding the fundamentals of how to design efficiently for seismic, and which is it's not easy. It's sort of it's all very tricky stuff. But when you're getting more than double the foundations that you need, then and you don't see it in the superstructures as much. I mean, that's sort of reasonably well covered in a steel bridge design course or the pre-stress concrete sections of building codes and bridge codes. And so, I see, okay, there's too many girders. It could be less girders. That girder doesn't need to be that deep. Things like that. Quite often you see a steel bridge where, in that span range, 34 meters should be a concrete bridge, and people are designing steel girders, and it's not going to be competitive and with the steel prices these days. But it's really the foundations where we really see inefficiency, and that's, we have structural and geotechnical engineers in our group. We're about half and half actually, and so we kind of, and that's where you and I worked together at KCB. We had the same groups in house, and it forces a kind of a higher level of communication between the two disciplines, and I think that kind of forces us to come to a better understanding of soil structure interaction and these things, right?
I think that's a huge point. The luxury of having internal teams that can debate, who's being too conservative, what are the inputs, where did you get this information from, are you just being overly conservative here, or like what are the sensitivities? In my experience, that's always led to the best outcome. But sometimes, since I stopped working with you, I've been doing a lot more hydropower stuff, and sometimes you're dealing with geotechnical groups on bigger projects that are either in another country or just within a completely different environment, and you always have that interface where there's a gap where you kind of, to a certain extent, you have to take what you're given and go, okay, especially in the US where geotechnical engineering is kind of its own responsibility, and some guy is stamps that, and you got to take what he gives you. He's a professional engineer and you got to run with it. So I think you're right. There's a lot of soil structure interaction, especially outside of the building realm. There's a lot of knowledge gaps, I would say.
Mm-hmm. Absolutely. Yeah, I had the great pleasure of sitting down with Alex C. Last week at a there was a conference here, a Geo Congress conference, and I spoke at it. I presented. I'm a structural engineer. Presented at the geotechnical conference, and I explained to the group. I said, I guess you're wondering why I'm up here, if I lost a bet or something. And yeah, that's right, I lost a bet. But I sat down with Alex and a fellow named Lee Yan, who was and they were the geotechnical engineers in the Lionsgate Bridge seismic retrofit. And we were recalling, this is 24 years ago. And we were recalling this story of we had H piles, which we were driving on the north approach as part of the seismic retrofit, and they hit cobbles and they were just shredding these H piles. And we went into the big rough tough contractor Don Smith, and with Don you had to sort of sit there and listen to. He had some war stories he'd tell you, and then he said, well, what are we going to do here? And so Alex and Lee, presented some options, and he said, well, that might work, but I need something that will work, boys. And then they discovered there was somebody was drilling wells locally, And they talked to him and said, can you drill through these cobbles? And they said, yeah, sure, no problem. So they came up with this, they took the biggest pipe pile that this guy could drill, and he had a barber rig. And this is what these things did, was they drilled wells, drilled that through the cobble there, and then just hammered it to get to the refusal criteria. It worked great. The guy who had been driving the H piles got thrown off the job, and he was pretty upset. And so he went and he bought himself a barber rig and started a company called Construction Drilling, CDI, and they are the biggest piling company in BC now, and they drill piles all over the place.
Wow.
And it all started there. But I repeat that story when you're working for a design build contractor. I use that a lot. So, look, I know what you need. You need something that will work. You don't need something that might work. We can give you lots of solutions that might work and it might be cheaper.
Yeah.
You got to cap your risk, right?
Yes. So another topic that I want to get your perspective on, because when you started, the world of software and analytical tools was very different than what it is today. So tell me about that, sort of the navigation from, your first exposure to finite element tools, how you kind of navigated through all of that stuff throughout the years, and just your kind of high level approach on how engineers should be thinking about the different tools that are available to them.
When I started at UBC, you actually did your computer runs with computer cards. Karen still has one which uses a bookmark in her box.
Excuse my ignorance. What is a computer card? What is that? It's like a floppy disk?
No, it's a piece of cardboard, like thin cardboard, and bookmark material. And you punch out all the different numbers and letters, and that's how and then you fire them into the computer. And you'd have a stack like this, which was your computer code that you'd written.
Wow.
And the computer would suck these in and read them, and that was how you told the computer what the code was.
Oh,
and
wow.
So they were just getting computers in it's 1981, right?
Mm-hmm.
Steve Jobs was just a kid.
Yeah.
What did they come up with a Mac in '84 or something like that? I don't know. Anyway, when we when I started working, there was GT Strudel was actually the program that we used when I started in '86 with Stone and Webster, and so there was sort of like one giant computer, and you'd sort of line up for your chance at it, and but then the world just started moving at lightning speed, and then I had a 286, which was had the memory of I got a phone. This is much more powerful than that computer, right?
Yeah.
And but we quickly had these structural analysis tools. And S-Frame was one of them, and I still use S-Frame. If anybody lets me, then most of the time these guys that won't let me. I say I can analyze that. No. Take care.
Yeah.
And
clients aren't going to pay for Bruce to be playing around on S-Frame.
No. That's exactly right. So, but and at H.A. Simons, when I started there in '88, they had their own internal software, and so there's a few companies that had done this. They'd written their own software, and they had a computer aided engineering department. There was 3 or 4 guys, and and so you were working with them, and they were actually running the programs. And then quickly we started to get our own PCs, and we were able to run those. And by 1992, we had some amazing modeling software that was coming out, where you were doing basically BIM models. We were doing a project that was, we had integrated an integrated analysis model, drawing production, and model that the other disciplines would work with, a common model to run interference checks and that sort of thing. So from, that's 10 years where we went from basically computer cards feeding them into the machine to we have basic BIM modeling, right?
Yeah.
In that decade, it was stunning. And then very little advance ever since, except for the speed of computers. And I mean, I shouldn't say that. I mean, SAP 2000 is very powerful. That we use that a lot around here in CSI Bridge. It's pretty powerful computers. And now we kind of get into a little bit of a problem with some of them. There's the black box. The input's so easy that anybody can do it, and they don't really understand what they're doing. And you can get some pretty goofy results because of that. So we're always pushing people to, you got to do the hand calculations and the basic stuff. We're still pushing people to do that, taking the fancy tools away from them. It's like, no, you can't run CSI Bridge. You have to do this by hand and figure it all out.
That was when I started using those tools. I always found it, I didn't have a sense of the magnitude of any of the results. So if I had a bending moment that was, 10 to the 19 kilonewtons, I didn't know if that was ridiculous or not. So you had no sense of scale of things. And even by just doing the most rudimentary hand calc, at least you will ground yourself somewhere in the realms of Earth, But I do remember when we would solve these different modeling problems, you often would advise us to run a model in two independent softwares. So it could be SAP 2000 versus Midas or versus S-Frame or CSI Bridge or whatever, to sort of cross-check one another. Do you still do that, or do you still believe in that?
It depends. I think the world has sort of moved towards having a certified software that your QC your QC people have gone through and everybody's verified. So there's sort of verified software, and once you're using that, then you can use that as build a separate model to check it. And that's what tends to happen around here is SAP is just our go-to, and we'll just have somebody will build their own model, and William does a lot of the checking, and he'll build sort of a high level model where he's just focusing on the area that he is tricky and things like that. I would rather do separate software, but it's everybody seems to in our company is really comfortable with SAP 2000, so that seems to be what they use. I keep pushing S-Frame, but I'm a dinosaur.
Yeah. What the issue too is just the learning curve of taking on a new tool. And every year that goes by, each tool becomes deeper. SAP is probably my most comfortable tool, but the last few years I've definitely leaned on a lot more Python for individual use cases, like what William is doing. If there's something that I'm particularly curious about, I'll model that separately using Python. And because it tackles the problem that you just mentioned, which is the black box approach. When you write all of the code entirely yourself, then you can easily figure out what are your boundary conditions, what are the key assumptions, what are all of the different pieces involved in this calculation. You can see everything.
Yeah.
Whereas, like you mentioned, if you
Interesting.
have a big SAP model, there might be a roller somewhere that you thought was a pin and you just forgot about it, or there's a spring somewhere that you forgot about, and it's like, why is this thing spitting out this weird result? I can't figure it out, and you lose sleep over that. And it's but I guess that's our job. That's engineering.
Yeah. 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 It is. It is. And there's the two. What I find is my larger value now is not. And when I left KCB, somebody told me this. Kristen said that we've got lots of people. We have a good knowledge base, and we have people who can tell us that's not going to work. But but Bruce's value was that he said this will work. Like, right? It's like, okay,
Yeah.
well, that ain't going to work, right? Well, what should we do? Well, I don't know. And I so I can usually wake up at 4 a.m. and it's I say I didn't really know. I didn't really feel like I knew what I was doing in bridge engineering till I was over 40. Like, that's what you're saying, right? That's how deep and complex this our world is. You really don't know what the hell you're doing until you're at 15, 20 years in, and it was still. A lot of I had a mentor, Ole Simonson, who was just fantastic, and he did that to me all the time. He would come by my desk. He was known as the best manager by walking around in engineering. And what are you doing? Well, I'm looking at this, and I'm working at. Well, how about you put it this way and put the bolt through that way, and that way the bolt's insurance. I'd be like,
Yeah.
Yeah, thanks. Yes, that's better. Go away.
Yeah.
And I said, oh gosh, I'll never get that skill, but I did, and it just took 20 years of practice, right, before you kind of get. And that's why people ask me about retiring, and I'm finally getting the hang of this. Why would I retire?
Yeah.
I'm just getting the hang of it.
So just a couple more questions before we finish up. And one is kind of just broadly, where do you see the industry headed? There's a lot of excitement nowadays about AI and how it's going to be integrated into different engineering practices. Like, what do you think of all of this stuff? Like, are you actively trying to figure out ways to utilize it? Do you think it's a fad? Where do you think this stuff's going?
The knowledge base of engineering and the specifics of our stuff is largely still in people's heads. It's not available. I mean, there's papers but it's so fragmented that I think that you can use AI to write proposals. And actually the CEO of Stantec was talking about this. He's talking about great strides that they're going to make by using AI to write their proposals, not in the engineering, right? And I think he's completely right. I think that the knowledge base is not there for machine learning and AI to really be able to come up with big advances. And shortcut stuff. I think it's just we keep the knowledge in our heads. We don't, write I've written a bunch of papers, but it doesn't even scratch the surface of what I've learned over this, and that's, in the old noggin here. And
Yeah.
so how can AI, so I struggle with that role beyond proposals. I mean, there's going to be, I see it sort of like there's going to be pockets of areas where it's just like, oh, we've been fighting with this so much, and here we go with AI, and it just solves this one little nugget. So I see it kind of fixing some nuggets for us.
Yeah. Yeah. I mean, the way I look at it is it's kind of like a calculator where it's an excellent tool to augment your thinking process and to allow you to kind of clarify your thoughts. Like, for example, sometimes if I have to write maybe a tech spec section about something like maybe it's a lifting gantry or something that I know what I want to say, but I just can't phrase it in the type of language that it should be in a technical specification. So I'll kind of spit out some nonsense that kind of broadly encapsulates, this is what I'm trying to say. This is how I want you to lift this gate in an idiot's terms. And then I feed something like that into AI with some, examples. And then it gives me, it's like, yes, that's what I was trying to say. And then I can, once I have the bones of it, I can flesh it out a little bit more. I can improve it and tailor it to get to where I want to get to. So I think stuff like that, it's very, very handy, but that's just a kind of it just helps as a thinking tool. I think we're many years away from any type of real engineering possibilities with AI.
Yeah. We did an experiment with it with we've got a tricky piling problem and sort of different types of soils, and so we were asking, we were trying to get one of the chat bots or something. One of my friends is a computer guy in Victoria, and he's really on top of this. And so I was working with him. I was trying to get this thing to tell us the answer of, what the piling refusal criteria would be, and the knowledge, it's just not there. It couldn't find anything that, and part of it is like, well, we don't know. So how, the humans don't know the answer to this yet. We'll tell you whether it works or not, right?
Yeah. So. Yeah. Okay, cool. Final question, Bruce. Any book recommendations or books that have influenced you throughout your career? It doesn't have to be about engineering. It could be about anything.
Well, way back, Ayn Rand, the Fountainhead, and these are when I was in my early 20s. The Fountainhead and Atlas Shrugged were they explained a few things to me. I'm trying to read some business books these days because they tell me as a president of a company I'm supposed to actually pay attention to this. I really just want to do engineering, but I really I've become a terrible reader. I used to read quite a bit, and I read very little anymore. It's in terms of books.
Do you think that's connected to just the availability of instant information on any screen? Do you think that's kind of like impeded the desire for a book?
I think so. I'm just as I'm bad. I'll just sit down and read the latest news on the phone or the sports news and stuff like that. So
it's bite size.
Yeah. This instant. I think it has. Now, my wife is a very good reader. Karen she reads a lot, and she hasn't sort of, but she is sort of consciously fighting that.
Yeah.
So
a magnet. Yeah. Okay, well, Bruce, thank you very much for a great discussion. Brilliant to see you, brilliant to talk to you. And maybe one day we'll have you back on again on Flocode, and we wish you all the best at everything at Basis. If anybody wants to figure out what Bruce is working on or wants to get in touch with some creative engineering design, have a look for Basis Engineering based in Vancouver, BC.
Thanks, James. It was great talking to you.
Yeah, likewise. Thanks for listening to the Flocode podcast. For deeper dives, please visit flocode.dev and make sure you're subscribed to our newsletter to stay in the loop on new content. And don't worry, we don't do spam. You can connect with me on LinkedIn. If you have thoughts, questions, or ideas, get in touch. I'm James O'Reilly. Keep innovating, and I'll see you in the next episode.